Okay, let me show you the contents of this video which I'm going to cover. First, I will explain the device control strategy, and then I will explain how the DTMF signals can be generated. After that, I will explain the DTMF signal recognition and the relay driver hardware. After that, I will explain the MATLAB code to generate these DTMF signals. And then later we will see that how we can build an application, GUI application, with help of MATLAB's App Designer. And then I will show you one MATLAB code in the last for building a DTMF application using this App Designer. So let's go ahead. So let's first see the device control strategy. So this is overall procedure by which we will switch on or off n number of devices. So here this is our DTMF encoder which will generate the DTMF signals. So when we press a key on the keypad such as 1, 2, 3 like that, a corresponding DTMF signal will be generated here. And this DTMF decoder will recognize this generated DTMF signal, and it will produce a 4-bit corresponding binary output. For example, if you press key, let's say 1, it will provide you 0, 0, 1, its binary equivalent here. And with help of this binary equivalent, we can drive a decoder, let's say 4:16 decoder, and we can use a relay driver to connect the different relays like this. And with these relays, your devices are connected. So we can switch on or switch off the various devices like that. So here this is your computer on which we are running the MATLAB to generate the DTMF signals. So we will write a MATLAB code to generate the DTMF signals. And this is the hardware part where this is the DTMF decoder. This is DTMF decoder. So it will recognize the input DTMF tone, and it will generate the corresponding 4-bit output. So this 4-bit output will be given to this relay driver circuit, and with help of these relays, our device are connected to the AC mains. Okay, so with the press of certain key, we can switch on or switch off a particular device with this method. Okay, so now let us go ahead. So first let's see what is DTMF actually. So phones use the dual tone multi-frequency, that is a DTMF, to dial the numbers on the keypad. And DTMF is a very reliable means of signaling used by the telecom companies to process information from the customers. So when a button on the keypad is pressed, a pair of the sinusoidal signals is generated. So this pair has one sine wave of low frequency, while the other sine wave is of the high frequency. So this is your keypad, 4x4 keypad, and the various frequencies are shown here. So for example, if I press this button 1, the two sine waves will be generated. One is of 697 Hertz, while other will be the 1209 Hertz. Okay, and similarly, if I press let's say button 6, then one sine wave of 770 Hertz will be generated, while other will be of 1477 Hertz. So this is how we can generate these sine pairs to distinguish each key press. So now let me show you that what type of sound I get, although all of you are well aware with these sounds, DTMF sounds, because every day when you dial a phone number on your keypad, you generally listen this sound. So let me press button 1 first. So I'm pressing this button first. Okay, so this is the sound when you press this button 1, and this is for 2, this is for 3, and this is for button A. So this is how we can generate the different tones by pressing keys on the phone's keypad. And as I said, when the button 1 is pressed, the two sine waves of 697 Hertz and 1209 Hertz are generated. So this is the waveform of the combinations of these two sine wave. It is just obtained by adding these two sine waves. Okay, And the frequencies are chosen to have the ratio of 21:19 to avoid the matching with the whole musical notes. The no frequency is the multiple of other, and amplitude of both the frequencies are kept same, and the standard duration of these tones is 40 milliseconds with the required gap more than 10 milliseconds between the two tones for correct recognition. Now let's see the DTMF decoder. So this is your DTMF decoder. So we have the input analog signal, which is your DTMF signal, of course, which is the pair of two sine waves, as I explained. And this is what we achieve as the output. So if you press the key, let's say 1, so at the output you will get 0, 0, 0, 1. That means simply the binary equivalent of 1. So this is the table. You can see the what output you will get from each key press. So these are your buttons or keys. So if you press 1, you get its binary equivalent. If you press 2, you get 0, 0, 1, 0, again its binary equivalent. So till 9, you're getting their equivalent binary representations. But for 0, we are not getting 0, 0, 0, because at every time when we do not press anything, we get 0. So it doesn't mean that somebody has pressed 0. So to avoid this false condition, the binary code of decimal 10 is assigned to this 0, and to the key star on the phone's pad, the decimal 11 is assigned to star, and to hash the binary equivalent of decimal 12 is assigned, and the A is assigned 13, decimal 13, B is for 14, and this is decimal 15. And this is the binary equivalent of the 15. That means all 4 bits are 1, 1, 1. Okay, so this is the table which are representing the corresponding binary outputs for each key press. So this is the hardware of DTMF decoder, which is based on this very popular integrated circuits, that is 8870. So this IC is quite popular and easily available, and even this circuit, the ready-made circuit, is available in the market. You can directly purchase, which is also of very low cost, around 100 rupees. So, or if you want to make it, it is also easy to make it with a very few components. External components are required. So in the coming slide, I will give it circuit. So this is your audio jack. So here you can insert a 3.5 mm audio cable, so through which you can give the DTMF signals to the circuits. And here you have the 4-bit binary output. So you can see, so this is Q1, this is Q2, Q3, and Q4. And these are the corresponding status LED. So if the DTMF signal is received for key press 1, obviously your output will be the 0, 0, 0, 1. And same here you can see with these LEDs. I mean, these 3 LEDs will be off, while this the last LED will glow because it is representing the logic 1. So it is easy to interpret that what output I am achieving with these visual indication. And as I said, that this DTMF decoder recognizes the input frequencies. So it utilizes actually the 8 bandpass filters, FIR filters. Their center frequencies are these 697, 770, 852, and 941 hertz. I mean the low frequency group. And other 4 are centralized at 1209 and 1366, 1477, and 1633 hertz. So which are the member of the high frequency group. So with help of these 8 FIR filters inside this IC 8870, it recognizes the input DTMF tones, and some digital logic converts that recognition into the corresponding 4-bit binary output. So this is the circuit. If you are interested, you can make it on the breadboard. It is quite easy. You need very few number of external components, few resistances, capacitances, and one crystal is required of 3.579545 megahertz. So here you will apply your input DTMF signal, and here you will achieve your corresponding binary output. And this pin STD, this actually represents the delayed steering output. So whenever a key is pressed and it receives a DTMF signal and it is recognized, it momentarily flashes. So this is simply the indication that something is happening, and the whole circuit works on +5 volt. Okay. And now let us see the device control, I mean the decoder and the relay driver. Actually, the DTMF decoder, as I said, gives 4-bit digital output. So with this 4-bit output, we can drive a 4:16 decoder. So we can control the 16 devices and each at a time. So this can be a scheme. So this is your input, binary input, which you are getting from the DTMF decoder. So suppose this is, let's say, 0, 0, 1. So obviously your pin 1 will be high. Actually, this IC 74154 is giving the logic low input, I mean the inverted logic. So this corresponding line will go low instead of high, and the rest will be the high. And there is a relay driver circuit just to avoid the loading of this 74154 decoder. And this relay driver is driving a relay, and a device is connected with this relay like this with AC mains. Okay, so such 16 devices you can connect with this decoder circuit. So now let us see what is inside this relay driver. So this is the circuit of your relay driver. So to drive a relay switch on or off, a relay driver circuit is needed to avoid any loading. So this is the input, so which is coming from the 4:16 decoder, or you can connect this circuit directly to the DTMF decoder. So at the input you are getting either 0 volt or 5 volt. So this relay will be activated if the input is 5 volt. Okay, so if the input is 5 volt, this transistor BC547 will be switched on, and there will be current in this branch through the collector, emitter, and the ground. So this coil of relay is getting current. So that's why this the center point of the relay will switch to the new position like this. So this circuit is complete. Okay, so your device will be directly connected to the AC mains. This diode is used for freewheeling the energy of this coil, and this is the LED indication which is used. So if your relay will be tripped, your LED will also be on at that time. So this is quite simple circuit, you can realize it. And this is the actual implementation which I will show you in this video. So this is my DTMF decoder. So here you can see that 3.5 mm audio cable is inserted, and the other end of this cable is inserted into my laptop. So from my laptop I will receive the DTMF signal. So these are the 4 binary output of this DTMF decoder. This is for power supply. So these 4-bit binary output of this DTMF decoder is fed to this relay driver. So you can clearly see that this is IN1, IN2, IN3, IN4. I mean the input 1, 2, 3, 4. This pin is for ground, this pin are for VCC. So these are power supply wires, and these are your logic wires. Okay, and for the relays, to simulate the load, I have just connected 4 LEDs as a load to or as a devices to these relays. Okay, so the whole system is working on the 5 volt. So now let us go to the programming part. So this is the simple program to generate the DTMF tones in the MATLAB. So I have created a function, okay. So this is the DTMF gen. You can give any name, and here I will pass the key, which key, for which key I want to generate the DTMF tone, okay. So here I'm defining the sampling frequency, and this is I'm defining the time vector. So since sampling is 8000, so going from 0 to 4000 means this is 0.5 second duration, okay. You can control the duration. So if you keep 2000 here, this will be 0.25 seconds, like that, okay. So now here I'm generating all these frequencies. I mean the frequencies of the low frequency group. So that is the 697 hertz frequency. So it is simply sine 2 pi f upon sampling frequency into t. So it's a discrete version of your sine wave. Okay, so this is your sine 2 pi. So this is your f upon fs into t. Okay, so this is your discrete sine. Similarly, you are generating sine wave of 770 hertz, 852 hertz, and 941 hertz. And these are the members of the high frequency groups. We are generating 1209, 1336, 1477. Here I have omitted the last column of the keypad, that is the A, B, C, D. So I am not implementing it. I am simply implementing the first 12, the primary keys. I mean the 1, 2, 3, 4, 5, 6, 7, 8, 9, star, 0, and hash. So I am implementing only this part, okay. So I have just neglected this. You can include in your project. And now I'm putting the conditions. So if the input key is 1, you simply add these two sine wave. I mean 697 hertz sine wave and 1209 hertz sine wave, and then by this function sound, this y1 along with its sampling frequency, you are playing this sound via your laptop's default sound hardware. So if you have inserted the cable, 3.5 mm module cable, then you will receive the signal through that cable. Or if you have inserted some headphone or nothing is inserted, then you can listen this sound via the laptop speaker, okay. So this is for key press 2, key press 3, 4, 5. It's quite simple, just you have to add the corresponding sine wave pair. And this is for key 6, key 7, key 8, key 9, and then this is for star, and this is for 0, and this is for key hash. So this is a very simple function, MATLAB function. So now let me jump to the MATLAB and let me run this program. So this is my editor. This program is already written. So since it is function, you cannot run from here. So just go to the command prompt and generate the sine wave, or I mean to say the tone for a corresponding key press. Suppose you want to generate the DTMF tone for key press 1. So what you need to write here, so you just call this function. So that is DTMF gen, and inside this you just pass the 1. So 1 means it's a key press 1. So when I enter now, it will create a sound. So just listen. Okay, so this is the sound which is generated for key press 1. Similarly, I can generate for key press 2. Okay, I can generate for key press 0, or I can generate for, let's say, key press star, key press hash. Okay, like this. So you can generate any DTMF tone for these corresponding 12 keys by this way. But here you can see that this is not a good way to generate the keys or to control the devices. it would be better if I could have a GUI, graphical user interface, where buttons are there. So it will be very easy for the user to just press those buttons to create these sounds or tones, DTMF tones. Okay, so let me show you that how we can create a GUI using the MATLAB's App Designer. So here we will see that the MATLAB App Designer to implement the DTMF generator GUI, graphical user interface. So for this purpose, we will execute this command at the command prompt. So it will open your App Designer window. So when you execute this command, your App Designer window will be open. In that window, we can create the GUI using this App Designer. So which is a simple process. I will also show you that can be achieved by simple dragging and dropping of different GUI components to that GUI window. So this is the graphical user interface, you can see, which I'm going to design. So these are your 12 buttons. Okay, some text is written here. You can write your own text. And so it will be now very easy for the users just to press any key with help of the mouse. Your corresponding DTMF tone will be generated. Okay. We will write the code for callback functions for each buttons to generate the corresponding DTMF tones in that App Designer. And now here only the codes related to the different callbacks are shown. I'm not giving the whole program which the MATLAB will write automatically, because it's a very lengthy one. And also when you go for App Designer and you will follow the process, you will get the same code, because MATLAB is writing for you. We do not have to write that code. Okay, so here I am just giving that part of the code which we will insert from on our side. So in auto-generated MATLAB script, just insert the following code segments which I'm going to cover. So first, what you have to do, you have to create a private property like this. So you just insert this piece of code in the auto-generated MATLAB script. So that is a properties which is of nature private. And here I am defining the sampling rate, that is 8000. So this sampling rate or this variable fs will be used for all the callback functions for each button. After that, you just create a helper function, so that this helper function will generate the DTMF tone for each key press. So this is again of nature private, because it has to be accessed inside the app. There is no need for outside interaction. So this is your function. So this is your output of this function y, and it is the name of the function, and these are the two input arguments, f1 and f2. So f1 and f2 are actually the frequency pair. So f1 is representing the low frequency, f2 is representing the high frequency. So here again the sampling rate is specified, but that will remain inside this function. And this is the time vector for 5-second generation. And this is how we are generating the low frequency f low. So that is again the same which I have already discussed, that is sine 2 pi your low frequency upon sampling frequency into the time. And this is your high frequency, sine 2 pi f2 upon fs into t. And here you are adding these two frequencies to generate your DTMF output. Okay. And after that, now we have to write the callbacks for each button. So when we press the button, so we can generate the corresponding DTMF output. So this is the code which you have to insert in the automatically generated MATLAB script. So this is the callbacks for button 1. So obviously we are calling that helper function whose name was func. And we are passing these two frequencies. So this is your f1 and this is your f2. So with help of f1, f2, it generates two sine waves of 697 Hz and 1209 Hz, and add them to generate the DTMF tone y1 corresponding to the key press 1. And with the help of this sound command, you are playing that sound. You're generating via your laptop's sound hardware. So, and this is the callback function for button press 2, and this is the callback for key press 3. This is for 4 is just repetition. For each button press, we are passing a different pair, so which is already shown in the starting slides. This is for button press 5. This is for button press 6. And this is for button press 7, for 8, for 9. This is for button 10. This is for button 11. This is for button 12. Okay. So all 12 buttons are covered here. So now let me jump to the MATLAB and let me show you that how you can design an GUI app using the MATLAB App Designer. So for that, you simply write App Designer and press enter. So App Designer will be open. Okay, so this is your App Designer window. And whatever you are seeing in the center, this is the size of your GUI. So you can resize it as per your requirement. So since I have to generate the shape like this, okay, so that will carry all the 12 buttons. So in the left side, you can see these different component of GUI component in the component library. So this is the button. So you simply drag and drop here. Okay, so this is your first button and you can resize it as per your requirement. So this is my button 1. Now what you need to do, simply duplicate it. Okay, so you don't need to resize it again and again. So this is second button, then again duplicate. This is your third button. Okay, so this is the first row of your button. I'm in the button number 1, 2, 3. So let me change the name. By default, the button is written here. You just go here. So in the text, you simply write 1, and you can make it bold. You can increase the size, or you can even choose the font. Okay, and you can choose the color also like this. So this is 1, and this is 2. Let me make it bold and of size 16. This is 3, bold, size 16, like this. So let me again duplicate it. So this is my button 4, and let me duplicate again. This is my button 5. It's quite easy to do. Again duplicate, and this is my button 6, and now button 7. This is button 7, and again duplicate it to make it 8, and button 9. Okay, so this is my button 9, and then duplicate again to create the button for star. So you can simply put star, and then duplicate, okay, and name it to 0, and then duplicate it for the last button, that is the hash. So this is the hash button. So this is how you can put all the buttons. You can write some text here. So this is the label, label A, and you can write your text like this. For example, DTMF generator, DTMF generator. Okay, so I have written the DTMF generator, and you can change its color, make it bold, and you can make it of large size. Okay, so this is your DTMF generator. So your app is ready now. So if you run it with this button, a GUI will be created. So first you have to save it in your working directory. So let me save it to my working directory as the name app1. Okay, so it is saved, and yes, it is compiled to create this GUI. So this is the GUI which you have created. So if you press these buttons, nothing will happen because we have not defined their corresponding callbacks. So we have to insert the code which just I have shown you in my slides. So let me close it. So here just see the two tabs. One is the design view, other is the code view. So when you press the code view, you get its corresponding code which is automatically generated by the MATLAB. But again, this code will not do anything because again this has no callbacks defined. So what I have to do, first you have to create the property. So what I have shown you in my previous slide, if you remember, so just go to that property. I mean this one here. So we will create the properties section in this code. So how we can create property, just go to here code browser, and here you can see the properties. Just press this plus button. So it will create a property section like this. Here you can see with this white strip, and you just write your code, for example fs equal to 8000 like this, and this is a description, that is sampling frequency. So this is the sampling frequency. You can so this is how you can define fs as property. Okay, after that you have to create the helper function like this. Okay, so again this you can do easily. So just go to this function tab in the code browser, function. So just press this plus button. A function is created like this. Okay, so function that is result equal to func app. So here I have used y, and then I have used the two frequencies f1 and f2. Okay, and inside the body of this function just copy and paste that code which I have shown you in the slide. Okay, and now let me define the callbacks for each button. So your layout is shown here. So just press this button 1 and right click, and here you can see the callbacks, and it says the add button post function callback. So you just press it. So again a white strip is created, you can see here, and this is the function button post app comma event like that. So inside this white script you have to simply copy and paste the code which I have already shown. So similarly you can create the function callback for each button. For example, for second button, so this is for second button, similarly for third button like that. So here you can see that these three white strips are created. Similarly for all 12 buttons there will be 12 white stripes. So in this white area, editable area, you can add those commands which I have already shown you in my slides. So this is how your GUI is complete, and after that you can run this command. Okay, so I have completed all the callbacks and all the helper function and the property. Here you can see, so this is a property and this is your helper function, and these are the callbacks for each button. You can see this is for button 1, and here you have just utilized that helper function. So y1 equal to func, that's the name of your function, and you are passing these two frequencies 697 and 1209, and this helper function is generating this corresponding DTMF tone, and you get that in the variable y1. So with help of this sound function you are playing this sound via your laptop's hardware, sound hardware. So this is the callback for button 2, this is callback for button 3, and so on, and this is last one, the callback for button 12. So your coding is complete. Now just press this run button, and this GUI will be created. So my GUI is ready to operate. So when I will press this button, a sound DTMF tone will be generated, and that I can listen. So just listen. I'm pressing the button 1. Okay, so you just listen the DTMF tone corresponding to the 1. Now button 2, button 3, this is 4, this is 5, 6, 7, 8, 9, star, 0, and this is hash. So this GUI is complete. Now I will connect my hardware, which I have shown you in the slide, and I will operate those relays, and I will show you that how I can switch on or switch off the devices with help of these buttons. Okay, so let me connect my hardware. Okay, this is my hardware, and this is the DTMF decoder module. You can see this is the 3.5 mm RA cable. The other end of the cable is connected to the laptop, you can see, and this is the relay driver circuit, and through these relays the 4 LEDs are connected as the load. You can see the current limiting resistors also, and this whole setup is running at the 5 volt DC. So now I will press the button on my DTMF generator GUI that is designed by the app designer. So you can see on the screen. So if I press the button 1, let's see how the relays will trip. So I'm pressing the button 1. Okay, so the button 1 is pressed, and here you can see that only the 1 LED is now glowing, because this is simply the binary representation at the LED side. So from the right side you can count these binary digits. I mean at the left side this is LSB, and at the right side this is MSB. So here the binary code is 0001 because the first 3 LEDs are off. Okay, and now I'm pressing the button 2, and let's see what will happen. Okay, so this is the binary representation again by the LEDs 0010. The second red LED is now glowing. Now I'm pressing the button 3, and yes, last 2 LEDs are glowing. So this is corresponding to 0011, and now pressing 4. So this is 0100, this is 5, this is 6, this is 7. Okay, 0111. You can see these 3 LEDs are glowing while the first one is off. And then this is 8, so that is 1000, and this is 9. This is corresponding to the 0, so which actually is a representation of the decimal 10, and in binary it is 1010. This is key press star, and this is key press hash. Okay, actually this relay model which I am using is not using a decoder, 4:16 decoder. So if I use a 4:16 decoder, then in that case only 1 LED will be on at a time. Okay, so this is how you can control your various devices. I mean up to 16 devices you can switch on or switch off, or you can have some more modifications to the circuit. For example, you can switch on a particular device, and you can switch off the same device when the same key is pressed again. So for that you can insert some Arduino hardware or some standalone microcontroller in between to detect such type of key sequences to control a particular device independently. So this is just basic framework, and you can modify it as per your requirement. So that's it for this video. I hope you have enjoyed it and you have something new in this video. So I thank you all for watching my video. Please like it, share it, and stay tuned for more such interesting videos to come. Till then, goodbye.